Everyone, welcome to another Android Developer Lab. um, so thanks for joining us. We are running 3 minutes late, but that's okay. Hopefully that's been giving you enough time to join. With that being said, let's get started with the news. The first bit of news is really exciting, and we're really proud of it. The Nexus 7 tablet has won Gadget and Tablet of the Year. So that's really awesome, really fantastic. We couldn't be prouder of the Android engineering team, as well as our partners ASUS. And other than being a great tablet for consumers to use, it's a fantastic development tablet too. So yeah, we're really happy. All right, moving on to more developer-specific news. We launched trials for subscriptions. So now you get a period where you can try the subscription app, not just magazines, but even apps. You can trial it for a little while before the user has to commit to purchasing it. So this is a great way for users to get a taste of the app before they purchase it. And we think it's going to be really beneficial for developers. The next thing is that this week has been Tablet Week. So, well, we said it was last week, and we certainly started off with it in our European team as well. We've published some materials this week. So the first was the blog, the Android Developers blog, and we talked about building quality tablet apps. It also had a link to this to our developer portal called Building Quality Apps. So on that Building Quality Apps, there's actually 3 sections, and one of them specializes on tablets. It is actually like it has a checklist to say, well, this is what makes a quality tablet app. So for those of you that are building phone apps and not building tablet apps, now's the best time to get in. Last week's ADL Plus covered fragments, which are really a fundamental piece of building apps for phones and tablets. So if you haven't seen it already, you should definitely view last week's ADL Plus app and then go along with this new checklist that we've published. Next slide, please. And over to you, Anirudh.
Okay, hi guys. So for today's talk, we're going to cover connectivity APIs for Jelly Bean. And we're going to announce something really exciting at the end of the presentation on connectivity APIs, so stay tuned. So what we're going to look at is what are connectivity APIs and what's new with Jelly Bean. So basically these are a set of wireless APIs, and they enable devices to communicate between each other. So they can communicate with the cloud, and that's about using your regular Wi-Fi to connect to your servers on the cloud and pull data. And they can also talk to each other. So some of these technologies that can enable this kind of communication are Wi-Fi, Bluetooth, and Android Beam, which is built on top of NFC. So and these have existed since ICS. We had Android Beam, and then Wi-Fi and Bluetooth have been there much before. So in terms of what's new for Jelly Bean, we introduced something called Wi-Fi Direct Service Discovery and Network Service Discovery, and these are the 2 topics we'll cover in detail. With the launch of ICS, we introduced Wi-Fi Direct, which is a peer-to-peer technology for connecting devices, and with Jelly Bean, we've kind of introduced Service Discovery along with Wi-Fi. So, so first look at what Wi-Fi is. Like I mentioned, it allows peers, which is 2 devices within their Wi-Fi range, to find and discover each other, and once they discover each other, they perform discovery, they are able to connect and then use sockets for transferring data. So and this can happen within, and it's kind of interesting because the Wi-Fi range is much larger than the Bluetooth range, and also the connection is high-speed connection with Wi-Fi. So it's a very interesting and fast way of connecting high-speed connections between devices. So which brings us to the new APIs in Jelly Bean, which is Wi-Fi Service Discovery. So with regular Wi-Fi Direct, which was introduced in ICS, you could connect 2 devices, and once you connect, you first perform discovery, and once the discovery is done, you get the network details of the other device, which is the IP address to connect to, and then you connect to the device. Once you connect to the device, your application sort of has to publish the services available through the application. So if your device is a if your app is a game, a multiplayer game, so only when the device was the other device is able to connect to you, you can say, hey, I have a multiplayer lobby available, and this is how you start exchanging data with me. So this wasn't actually a very good user experience, that you'd have to connect to devices to figure out what services are available. So that's where the Wi-Fi service discovery comes in, Wi-Fi direct service discovery. And it's a pre-association discovery, so you can actually find services before establishing or associating yourself to the AP, which is the access point. So you can figure out what services are available, and if you're really interested, you can connect to a particular device which is hosting that service, or the app that is hosting that service on the device. So the devices, and this comes from Wi-Fi Direct itself, the devices are not connected to a network, don't have to be connected to a network. You do not have to have an existing Wi-Fi network around, a classic router-based access point around. The devices can just connect to each other whenever they're near the Wi-Fi range of each other. So, which basically means before they're assigned the IP address on the network, they are able to discover each other. They discover the services and the device itself, and then, if interested in the service, establish a connection. So this actually leads to a very better, really improved user experience. So you browse the printing services and file transfer services that are available nearby, and then you connect to a device that you want to. So some of the key APIs for Wi-Fi P2P are, okay, some of the key APIs for Wi-Fi P2P are, sorry, we've got a video feed from someone. Let me see.
Are we getting some echo? Are we, Anirudh? So we'll just mute them.
All right.
Great.
So some of the key APIs available from as part of the Wi-Fi P2P services service discovery APIs are, and these are the objects listed. So there's a Wi-Fi P2P service info, which encapsulates a Wi-Fi P2P service, which is, and P2P here stands for peer-to-peer, which is Wi-Fi Direct. So there's a Wi-Fi Direct service info object which encapsulates a service which you want to publish. Then there's a service request. And then there are two specializations of these service request and service info. One is a DNS-ST. This is a DNS-based service discovery. And the other one is UPnP, and this is a popular universal plug-and-play protocol that you find in a lot of media devices and DLNA-compliant devices. And this is used, this is kind of specialized for media technologies like rendering and publishing streams of audio and video. So there's a specialization for a DNS-based service and a plug-in UPnP-based service. So now we're going to get a bit more technical, and we're going to see, take a look at code and some code snippets to see how does this actually work. So the first thing you want to do from device A, which is the first device that's interested in connecting or is interested in being part of a peer-to-peer exchange, will publish a service. So before you can actually connect to a service, you need to publish a service. So you create a local service object, and what you do is you have an instance name and a service type. So the instance name is something really that your application is. So this could be test, or my chat, or my printing service. And then there is a service type, which is a standard name that's followed. And these list of names are registered with INA, which is a body that manages the service types. And so if you're publishing a service that's not already included as part of the INA services, you can register your service type with the INA and body, and then use a service type. So this would typically be something like, so for example, for chat service, we use something called presence, and presence is the name for a chat service. So your service type will be presence. And similarly, there are names for printing and for other network services. So, all right, so what we've seen is you're able to create now a local service object, and then you register this local service with the Wi-Fi P2P manager. Wi-Fi P2P Manager is a system utility that's it's a framework class that's available to you just like the connectivity manager or the telephony manager. You say context.get system service, and then you say Wi-Fi P2P Manager, and you get a handle to the manager object. So we've seen the part of where a device is able to publish a service. Now, on the peer device, which actually wants to use the service or consume the service, you will create a service discovery request, and then you will go ahead and perform a service discovery. So first, you create an instantiated object that describes your request. Basically, you have some fields that we will look into, and then you ask the Wi-Fi P2P manager to perform the discovery. So when you're implementing this in Android, so first thing is some of the permissions. You need a change Wi-Fi state and an access Wi-Fi state permission, and also you need internet permission. It's not because we are going to exchange data over the internet. It's only because we are going to use sockets to communicate between the devices, and if the internet permission is tied to sockets usage. So you would require this permission as well in your manifest. So now at a code level, and these are really snippets of code, and it's pretty easy to write this code, just 2-3 lines per operation that you want to perform in. So the first thing we looked at is a peer adding a local service. So here's the service class that we talked about earlier as a key API. This is Wi-Fi P2P DNS service info, and we just use a static initializer on that saying new instance. And the two things that you're looking at, the parameters, they are the ones, the instance name and the service type. So the instance name is our instance of the service, which is _test here. And because it's a kind of chat service, so we are using a standard name for the chat service. And notice the naming convention here. This is followed for all the services type for all DNS-based services. So it's _ service type _ the protocol it's going to follow over the network. So the third thing is really interesting. It's a record, and this is a DNS text recorder. And this is also pretty much standard, and this carries additional metadata about your service. So for example, if it's a chat service, and along with saying that you have a chat service, you also want to say that as a user, I am available to chat at this point of time, or I am busy and I cannot chat. So the service is available, but you are busy and you cannot respond to chat messages. So DNS text record is kind of a key value thing, and this is where you can publish some additional metadata about your service. So, and you can keep publishing these records, which these records can change over time. So your service is published and it's available as a chat service, and then you can keep pushing DNS text records saying, I'm available at this point of time, I'm not available, I'm busy. So once you've done that, we add the local service to, and the mmanager object that you see here is the Wi-Fi P2P manager, and then you add this local service, and there's a callback. Many operations, or almost all operations of Wi-Fi P2P direct and DNS network service discovery are asynchronous, and you always register a callback for success or failure. And so this is kind of a standard template for all operations of network, for all operations of service discovery. So we instantiated a service info object which had our instance name and service type and a DNS text record. And so once we've created that, we go ahead and say my manager.add local service. And as soon as you do that, your service is published over the Wi-Fi P2P network, Wi-Fi network. And in case there's an error, you can handle that error and show appropriate messages to the user. So like I said, all the operations are asynchronous. So every time you perform an operation, you're going to pass a callback or register for action listener, like a success failure. And because it's asynchronous in nature, you don't have to worry about where you're placing this call. It can be in your main thread. The underlying network call is always off the main thread. So you don't have to worry about writing asynchronous async task and then placing these calls there. They're inherently asynchronous. So, all right. we've now published a service with those two lines of code. Uh, so the other device, the other peer that's interested in consuming is, and where your app is running, if it wants to discover the nearby service and connect to it, it first needs to create a DNS SD service response listener. So which basically is a callback that has one method which says on DNS SD service available. And we talked about UPnP, and this is the same kind of mechanism that we follow around for UPnP. So when there is a UPnP service available, you will see on UPnP service available with a UPnP service response listener. So this is a callback. The method on the anonymous implementation there is called when the framework is available to discover a service. When the Android device discovers a service, it's going to give you a callback there. So first thing you do is you instantiate a service response listener, and you set it in the manager. So you say Wi-Fi P2P manager, here is my service response listener. In case there's a service, call me back. So we've set our response listener, and then what we want to do is actually create a service request. And this was, again, if you remember, one of the key APIs. So you will say, use the Wi-Fi P2P service request object to get a new instance, again, a static initializer there. And once you're able to get a service request, you add the service request to the Wi-Fi P2P manager. And again, there's an asynchronous callback, success failure. Once this is done, you actually go ahead and perform discovery by saying manager.discover services, and then this is when the framework actually starts discovering your services. You've already registered a response listener, you've given your service request, and now the framework is able to perform discovery, and if it finds something, it's able to call back on your interfaces. So once a service is DNS SD service is available, you will also receive a Wi-Fi P2P device object along with it. This is basically a structure that has details about the peer, IP, and other connection related details. And this is when you can actually go ahead and perform a network connection. So you're able to query the Wi-Fi P2P manager for nearby services. And suppose you find a service, maybe a printing service or maybe a chat service that you want to connect to. At this point of time, which is after performing discovery, and the framework gives you a callback on your interface, you can now say, you can now receive the connection details and go ahead and perform connect to the other device. And this basically means initiating an access point association. And so that once this is done, you're on the same network now. You get assigned IP addresses on the same network, the same Wi-Fi P2P network. And once this is done, you're able to open sockets because you're on the same network now. You can open TCP sockets and start exchanging data, which is your app data. So what the framework is really giving you is a mechanism, is sort of a framework for publishing your services and consuming other services, discovering and consuming other services. So this was completely Wi-Fi P2P, which is based on a Wi-Fi peer-to-peer network. So the condition there was there doesn't have to be an existing network. Two devices capable of Wi-Fi P2P direct will find each other, discover the services, and connect. And the other thing is the other API that we introduced is network service discovery. And this is basically based on the fact that you're already part of the network that you want to join and discover services. So you're connected to the network already. And in this network, you want to discover services in your which are available in your local network. So this is pretty similar to Bonjour if you've worked with Bonjour on the Apple systems, or there are other ZeroConf networking solutions available on Linux and other platforms. And this is basically bringing the same DNS-based, multicast DNS-based service discovery to Android. And we call it network service discovery. All right, and like I mentioned, it's different from Wi-Fi Direct because Wi-Fi Direct, we didn't really need a network, and this is when you're actually logged into a local network. So if you suppose you bring your device to your workplace and you connect to your corporate internet, your intranet, and you have some printers available and you want to print maybe some document, that's some PDF from your mobile phone, and if the and many of the printers understand what is network service discovery and multicast DNS. So you can discover these printing services available and go ahead and print after you're able to make a connection. And again, file sharing is one of the big things on the local network, and multiplayer gaming. Multiplayer gaming is really useful and can really benefit from technologies like Wi-Fi, P2P direct, and network service discovery. So going into technical details of how it works, in this case, you will create something called a registration listener, and this is a device that's publishing a service. This may already be an existing device on the network, or it may be an Android device which is offering maybe a multiplayer gaming lobby, and or a chat service. And this is how it will go ahead and publish its service. So you create something called a registration listener. In terms of DNS-based network service discovery, we call it registration instead of saying publishing your service on the network. So the naming convention is followed here. So you register your service on the network by creating a callback for registration listener, and then you again have the same kind of details. You have the instance name of the service and the type, and the service type is compliant with INA. And so here is some code. Basically, it's again a callback, an anonymous implementation of registration listener, which has some standard methods, which is your service has been registered, on service registered, on registration failed, on service unregistered, and on unregistration failed. So the framework is going to call any of these methods when depending on what really happened with your request, and so you can listen to these notifications and show the proper UI or go ahead with actually connecting to devices. So once you've created a registration listener, what you want to create is a description for your service. And again, we use something called NSP service info. The class is similar to we looked at earlier as Wi-Fi P2P service info. So the NSD service info, here we set the service name, the service type, and the network port it's going to run on. Because we're already in the network, we can specify what port my service will run on. And you get a handle to NSD manager, same as Wi-Fi P2P direct and other system services. You say context.get system service, and you get a handle to NSD manager. And once you get the manager handle, you created the registration listener. You can say register my service. Here is the info of the service, and here is registration listener, which is the callback where the framework will call you back depending on what really goes on with your request. So with this, now you've registered your service. So as you can see, it's just 2-3 lines of code per operation, and it's pretty easy to implement. So now you've registered your service on the network. A DNS-based network NSP service you've registered, and now you want to discover those services. So what really happens behind the scene is multicast DNS technology is involved here. You're listening to a network broadcast, and using some framework APIs, you can filter out what services you want to consume or do not want to consume. And again, it's asynchronous API, just like Wi-Fi P2P direct. All the operations are performed off the main thread, so you can make your call anywhere. Just like registration listener, when you're discovering services, you create something like discovery listener, and this will be used to initiate service discovery. Again, as you would have guessed, it's a callback which the framework is going to use to call you back on when it's able to find something for you. So there is on discovery started. The framework has started discovering services. Again, time to update your UI, tell the user that we are locating service, we are finding services. On service found, you get the callback with the service info, what really that service is. And this is where you can perform filtering. If you're not interested in connecting to the service, you can filter out the service. And there are some other callbacks on when the service is lost. Suppose the other device goes out of network or goes down, you get the service lost. Well, discovery is sort of an ongoing process once you kick it off. So you can actually request the framework to stop discovering, and that's when you get the callback on discovery stop. And some other callbacks on if something failed, discovery or stop discovery failed, you get a couple of other callbacks. So now now you've created a discovery listener, and what remains now is to request discovery. So you say NSD manager dot discover services. Here is my discovery listener, and you get the callbacks with when the framework has an update for you, which is it's able to perform discovery and find some service, or it failed. It gives you a callback on your discovery listener. So all good. If the framework is able to find your service, uh, what you do, and this is on the callback on service found. When it's able to do that, you instantiate something called a resolve listener, which is to find network details of the peer so that you can connect. So the resolve listener will have callbacks again on when the framework is able to resolve the service for you, which is resolve the IP for you. And then you call the framework once you create the resolve listener and provide an implementation. You call NST manager or resolve service, and that's it. You get the IP details of the device or the network machine that's publishing a service, and it's time for you now to connect. And the connection is here basically sockets like we discussed earlier. You're on a network, and if the service is TCP based, you create a TCP socket or datagram. So to summarize, we've looked at two new key APIs, which we like to call connectivity APIs, and these are Wi-Fi P2P service discovery and Wi-Fi direct service discovery and network service discovery. So while Wi-Fi P2P service discovery protocol has a DNS and support for UPnP implementation, the thing about UPnP now is that it's closely tied up with associated with the DLNA protocol that's used between many devices. Your HD televisions, your PlayStations, your Xboxes, your a lot of media, DVD players, Blu-ray players. They're using a DLNA protocol to share and stream media. So one device is kind of acting as a stream device that's streaming the media. The other sort of acts as a renderer and is able to show what the other device is streaming. And this is all working on top of DLNA and UPnP protocols. So Wi-Fi P2P service discovery provides you the ability to connect and publish these services. You could be the media renderer, or you could share media. And then there is network service discovery, which we looked at, which is sort of a zero-conf networking thing that's sort of similar to Bonjour. And you're able to find DNS-based services on the network. So, and with this, you can find services when you're not connected to a network using Wi-Fi P2P Direct, and when you are connected to a network using network service discovery. So this kind of brings us to the end of the presentation here.
Thanks, Anirudh. So Anirudh's obviously covered a lot of things today about all the sort of options that you have when it comes to connectivity on Android. And we think that the capability is great, and what we'd like to see is more people use it and sort of impress us to show us how what are the creative things you can come up with. So today we'd like to announce something new that we're doing. We're calling it ADL Plus Experiments, and we're going to launch our first experiment today. So what ADL Plus Experiments is it's a plus page that you should go ahead and circle, and this announcement that we're just doing right now, we will be making the same announcement on the plus page as well. So ADL Plus Experiments is a way for you to get involved with the things that we present. And today we're launching our first experiment, which is based on the connectivity APIs that Anirudh has presented for us. So the goal is very simple, actually. You're tasked with building a cool app. This is obviously optional for you to whether you want to get involved or not, but we think this is a really great way to showcase your talents to the rest of the developer community. So build a cool app, come up with some great concept using these connectivity APIs, and then what you should do is share that APK with the Plus ADL Experiments page. So just send us a link to the APK, a download link, whether it's Google Drive or Dropbox or any other sort of service that you may use. And when you share it with us, tell us what the app is, and more importantly, how to use it, and tell us what makes it special. You can choose to share the source code if you want, whether if you're using like a GitHub repository or otherwise, Google Code, for example. And yeah, we'll take a look. And so what we're kind of doing, and this program in itself is quite an experiment. We're launching it for the first time. So it's a way for you to showcase your talents. It's a way to sort of energize the community, and by all means, you can collaborate. So send us these submissions. We've kind of put a date, a cutoff date of the 30th of October. As we get and feel free to send it before then. As we get submissions, we're going to go through them, and after that cutoff, the incentive for you is we'll pick a handful that we think are really really nice, and we will highlight these apps. So it'll drive some downloads to you. But more importantly, we'd like to invite you to a future ADL Plus, so you can tell us how you built the app, what challenges you had, and have other people ask questions as well. So try and utilize these topics that we're presenting, and yeah, that's ADL Plus experiments. Anirudh, is there anything you want to add to that?
Just for this specific topic, if you want to learn more, there is an Android training available called Connecting Devices Wirelessly, and this can help you with your first experiment. So go ahead and take a look. It's published on our Android developer site.
So hopefully this means that people are going to start submitting apps, some work that they're doing. And these things don't need to be complete apps. They don't need to, be published necessarily. If they're published on Play, that's great. But these can be just, tech demos effectively, where you're showcasing something cool that you're doing. We love this developer community, and we're trying to see how we can get you more involved in the ADL Plus. So ADL experiments, we really hope you engage, because it means that if you find this sort of thing useful, then we'll do more of these experiments in the future. So we're going to talk about this or mention ADL experiments every week up until that code cutoff, and then in a future ADL Plus, we'll try and showcase some of these apps, and see if we can bring the developers on as well. So with that, we shall move on to Q&A. We have one person that's live on the Hangout at the moment who hasn't said anything, but did you have any questions to ask before we shift to the moderator page? Doesn't look like it. That's okay. So we have a couple of questions on moderator. I'll read out the first one. I get errors from ICS users with map activity. An exception, which is basically a no class definition exception found, android.security.messagedigest. If I Google the error, people say that it's a problem because an old version of map API is on the device. How do I solve the problem? The target SDK is version 16. So I had a look at this, and there seems to be there's a handful of cases where this has sort of been reported on Stack Overflow. I wanted to ask you, you said ICS users, but on those Stack Overflow threads, there were people with ice cream sandwich devices that were saying, hey, this works fine for me. I don't have problems with this APK. So I must admit, this is an issue that I haven't heard of before. I'd love to get down to the bottom of it. So this is Mackin from Sweden, and I apologize if I've messed up the pronunciation. But please reach out to me on Google+, and let's see if we can diagnose it further. I'm interested in knowing whether the devices that you were testing on are, is there something special about them? Are they normal ice cream sandwich devices that you buy from a shop or from your telco, or are they running custom ROMs? Is there a chance that these devices don't have the Google services on them because they're running a custom version of the platform or something along those lines? And more importantly, are you saying every single ice cream sandwich device is struggling to run this APK? So please reach out to me. I'd love to follow up further. Anirudh, did you want to add anything to that?
No, I think just give us some more info and we'll probably be able to help you.
Yeah, we should definitely try and get to the bottom of this. All right, so next question. I'm new to Android development and don't know how to design and develop any app. Could you please give me some references from where I can learn about the environment setup and app development? Thanks. So this is Harshad from Mumbai, India. Look, the best place to start is developer.android.com. There's a section called Develop, and there's a Getting Started guide there. It shows you how to download the SDK, how to set it up, and it even has some sample apps that it helps you sort of build. There's tutorials there. So developer.android.com, it's the place where you'll find all of our tools. It's where you'll find all of our documentation. If you have any sort of specific questions, you should definitely be posting to Stack Overflow using the Android tag, and you'll have a huge community of Android developers that'll be just ready and willing to help you. But the important thing is that your question is very broad. You're saying, hey, look, I don't know how to design or develop any app. It's really important to just sort of get your hands dirty, start playing with the tutorials, start writing sample apps. And in the beginning, it may be hard. You may feel like, hey, this is not a very high quality app. That's okay. That's how you learn, and that's really the focus of it. Next question. Can I retrieve data from the Google Maps API so I can use it for my location-based service application that I'm developing? This is Prissy from Philippines. Anirudh, do you want to take this one?
Yes. So the API that's available is called Google Places API, and that's what you would probably like to use with your location-based services available. You can use this API. It's a REST-based API, and there is a token you need. So what you need to do is go to your developer console, which is code.google.com/apis/console. This is where you create a project whenever you're trying to use any of the APIs here. So there you need to enable Google Places API, and I think there is some quota that's available to you free, and then you need to pay beyond a certain number of requests. So if you're just trying out, you could probably try for free. And there is Google. And the Google Places API is there. And if you go to our developer website, developers.google.com, you can look up the service reference and all the API reference and the different clients available to you. We do have a Java client, Google Java client library. And yes, you can pretty much use those, the Places API. And if I remember correctly, I think Reto Meyer, one of our advocates, you probably know him, he published a tutorial on location-based services, and he also shared the sample source code. So if you just look up the history of the archives of Android Block, you would probably find this tutorial. And he is using Places API there to fetch places of interest for an location-based service, basically allow users to check in where they want. So go ahead, and there's a lot of a complete application that is written there. So you'll find a lot of sample code there on how to use or consume this API.
Cool, thank you. So, final question: why can't the Google Play Store send back the install referrals back either at the Google Play Developer Console or through an API? Currently, the in-device install referrer process is broken. We have big product marketing plans around that feature, and that's from Gopinath in Bangalore, India. Do you want to take this one as well, Anirudh?
Yeah. I don't really know if it's not available. If it's not available, I would say that this is a feature request we can take up to our team. So just hang on to your big product marketing plans before it's released, and I'm not even sure if it's going to be released. We will just take your feedback to our product team and see how they want to prioritize this. Yes.
Yeah, I was under the impression that something that definitely we do support referrers, but I think the key thing here might be in the question he mentions about the in-device experience, or on-device, I think is what he meant. That the referral process might be broken, because if you do it via the web, I'm pretty sure that process works pretty well. And I'd be surprised if it didn't translate well to the device. So, yeah, let us look that up for you and run that past our team and see if we can get a response. So please do reach out to either Anirudh or myself, and we're going to look up the answer anyway. But there's no way for us to contact you directly here. So yeah, we'll do that. just so you know, this question I think is a fairly new question. It wasn't there a couple of hours ago, so we haven't had the opportunity to have an answer ready for this one. All right, well, I haven't seen any questions on any further questions on moderator. Are there any questions on the thread where we've hosted this? Jan Felix, can you just check the? We're just checking the thread. No, there doesn't seem to be. All right. Well, thank you for joining us. Look, we mentioned before that we were announcing something, and it was ADL Experiments. It's really for developers to get their hands dirty with this stuff. So we hope that's useful for you. It's exciting for us because we get to see some of the creativity that developers come up with when using these new APIs. So thanks, Anirudh, for presenting connectivity, and thanks to all of you for tuning in. So that's us signing off for this week. We'll catch you next week.
All right. See you guys.
See you later.